Hey guys, welcome to all. You are welcome in Electrical Wala session, Neeraj Verma. So this is, I think, a fourth video lecture. So if you have not watched before this video lecture, then please go on a playlist and watch before I mean three videos. Then you will able to get more interest in fourth lecture. So in this lecture, we will have to cover the point number 17. So point number 15, 16, 14. Before that in video lecture we had covered. So now we have to cover the ohmic and non-ohmic conductor. So without wasting our time, we come on our topic. So this is the point number 17 in which we have to study about ohmic and non-ohmic conductor. It's really important. What is ohmic conductor and what is non-ohmic conductor? Then, so first of all, we have to just go through the definition, I can say, of ohmic conductor. Those conductor which obey, yeah, Ohm's law is known as ohmic conductor. As we know, Ohm's law means V directly proportional equal to I, and I directly proportional to V. So this is ohmic law. Those conductors which follow or obey Ohm's law is known as ohmic conductor, right? And those conductor which not follow Ohm's law. In this definition, same thing mentioned as I mentioned just a second ago. Those conductor which does not follow Ohm's law is known as non-ohmic conductor. So first of all, we should have to clear in point number 18 what is Ohm's law. So Ohm's law means the current flowing through a conductor is directly proportional to potential difference, right? When temperature is constant. मतलब this means current flow in a conductor is directly proportional to voltage when the temperature is what? Temperature is constant, right? Temperature is constant is known as Ohm's law, right? So here is a matter of thinking what is Ohm's law and what is ohmic conductor and non-ohmic conductor. So we can clear by this graph. This is a graph, and in which this is a voltage and this is a current. So current is taken in a milliampere and voltage is taken in a volt. So if it's in a directly proportional, then obviously it's a graph will comes from origin and in a straight line. So those conductor which follow Ohm's law, their graph is in a straight line, but those who not follow Ohm's law, their graph is in a exponential form. So this is the way we can define or we can underestimate the ohmic conductor and non-ohmic conductor. So I hope ohmic and non-ohmic conductor is clear. So right now we have to come on a point number 19. What is electric power? So electric power is what? If I go through definition, then electric appliance is the rate of which electric energy is converted in the form of energy is known as electric power. In another way, we can define as the rate of change of work done per unit time. Work done is write as Q into V, because we know that volt is equal to work done per unit charge. So from here we can write W equal to work done equal to charge into voltage. So when we put here electric power, as I told you, electric power is work done per unit time. So work done can be write as Q into V upon time. So as we also know, Q equal to I into T, right? I into T. So when we write I into T, then what we'll get? We will get this form of electric power, right? So electric power is simply we can write as V into I, right? Why? Because here T is cancelled to T. Then electric power P equal to V into I. Voltage into current is known as power, right? Otherwise we can write in another form, because as we know, when we put V equal to IR, we know, so in the place of V, when we replace with IR, then we got P equal to power equal to I square R. Same in a same sense, if we write in a voltage form, if we have to find, then in voltage form the formula of power is V square by R. So this is the three formula which we have to just keep remind in our mind to solve the question very easily, because this is really important. We don't know in competition question which type of question will come in a competition exam. In the sense of voltage, in the relation of voltage and current, or current into resistance, or voltage with resistance. So this is really important to know the all this formula of power. So now we know that power is measured in a watt, right? So this is known as I think here we have to just cover unit of power. As I told you, unit of power is measured in a watt. And 1 watt maybe we can mention as if in a conductor, I mean, yeah, conductor in a 1 ampere of current is flowing, as well as 1 volt current is flowing, then we know in a conductor I mean have 1 watt, right? So now we have to just know about what is what is kilowatt and megawatt. Kilowatt means 1000 watt is known as 1 kilowatt. So 1 kilowatt may be write as 10 to the power 3, 10 to the power 3, 10 to the power 3. 1 kilowatt equal to 10 to the power 3 watt. And 1 megawatt equal to 10 to the power 3 kilowatt. In watt, 10 to the power 6 watt. So we have this is really important, this is really important regarding to our examination to solve any numerical. So I hope you will learn this formula to solve your question too easily, right? So now we have to just go on I mean point number 20. Point number 20 is electrical energy. What is electrical energy? So the loss of e- electrical potential energy in maintaining the current in a circuit is known as electrical energy consumed in a circuit, right? This is known as electrical energy. So now we have to know what is electrical energy consumed. So W equal to Vi into T, as I mentioned above. So here if we I mean express V equal to I into R, then now we find I square RT. After that V square R by T. And this is energy is measured in joule, as we know very well. So this is point number 20. And now we should have to know about another point, commercial energy, commercial unit of energy. In a practical, electrical energy is measured in a kilowatt hour, right? Kilowatt hour. In practical, in electrical energy is measured in a kilowatt hour. So 1 kilowatt energy is consumed when a device converts electrical energy into another form at the rate of 1 kilowatt for a time of 1 hour. So what is the meaning of this? I mean commercial unit. Commercial unit means uh, energy, I mean kilowatt per hour, right? So 1 kilowatt per hour, if any equipment 1 kilowatt per hour consumed, then is known as commercial unit, right? 1 kilowatt hour, right? So this is how we can know about commercial unit and what is 1 kilowatt. And finally last one is I think point number 21 of this chapter, basic concept. So use of power and electrical formula. So electrical power, as we know, P equal to I square R and V square R, and W equal to I square RT. I mean power is multiplied by when power is multiplied by time is known as what? Energy. Whenever power is multiplied by time is known as energy. So that's why in the formula of power, here we know this is the formula of power, and whenever we multiply by time, then is known as what? Energy. So this is how we can make the relation between time and energy. We can know, not relation, we can know what is the difference between power and energy. Only the difference of time. When we multiply by time, then power is converted into energy. And now we had to know about electrical. Last point, this is the last point, 2022. So 22 point, what is saying? Electrical material. There are three type of material. I hope you know very well. It's a very simple: conductor, semiconductor, and insulator. What is conductor? I would like to clarify here. I don't want to go in a deep sense. It's only given in a point way, so we can just know what is a conductor. Conductor is a those material in which electricity flow easily. Electricity electricity flow easily, right? Electricity can flow very easily, it's known as conductor. And insulator is opposition, just like opposite of conductor. In those material in which electricity can't flow easily is known as insulator. And semiconductor is an intermediate state of conductor and insulator. I mean intermediate state of what? Conductor and insulator. Current, I mean in semiconductor, current is flowing little bit as well as current is not flowing little bit. I mean in a simple way, it's an intermediate state of conductor. And we can say a semiconductor as a conductor as well as a insulator, but we can't say this is the only conductor and one insulator. So that's why this is known as semiconductor. This is intermediate state of intermediate state of what? Conductor and insulator. So now uh, here is a graph, and this graph is really important according to resistance and time graph. Resistance and temperature graph. So what's the resistance and temperature graph mention? When positive coefficient of temperature is given, then is known as conductor. When negative coefficient, then is known as insulator or semiconductor. And this is a zero coefficient, this is a reference one. And I mean we take this is a reference one coefficient, and this is a positive one and this is negative one. Positive one for conductor, negative for insulator and semiconductor. So I hope in this oh my god, now this chapter is completed of basic concept of VK Mehta. And I hope you will got interest in this chapter. And if you'll sure I mean watch this video at last end, then obviously you got some knowledge. And I tried my best to be I mean make it simple and easy way to understand. So if you watch this last, then don't forget to share it. I hope you will find make interest in then video. Then it's not my I mean mentioning from my side to subscribe this channel. So lastly I would like to say thank you.